This is a differential equation where employing substitution reduces the equation to one of the previous types of order 1 differential equation. The first step that we will do is to distribute dx and dy, which will give us dx plus quantity x plus y squared times dx plus dy plus x times the quantity x plus y times dy equals 0. Now, we will rearrange the terms by placing dx and dy on the right hand side of the equation, giving us quantity x plus y squared times dx plus x times the quantity x plus y times dy equals negative dx minus dy. We will let u be equal to x plus y, and by implicit differentiation, du is equal to dx plus dy. We will proceed to replace x plus y with u and dy with du minus dx, which will result to u squared times dx plus u times x times the quantity du minus dx equal negative du. We will divide each term by u and proceed to distribute x to the quantity du minus dx, which will give us u times dx plus x times du minus x times dx equals negative u raised to the negative 1 du. The next step that we will do is to bring each term to the left hand side of the equation, which will give us u times dx minus x times dx plus x times du plus u raised to the negative 1 times du equals 0. We will now factor out dx and du, which will give us quantity u minus x times dx plus the quantity x plus u raised to the negative 1 times du equals 0. Now, we will proceed to check for exactness. To check for exactness, we will take the partial derivative of m with respect to u, which is equal to 1, and the partial derivative of n with respect to x, which is also equal to 1. This means that this is an exact equation, and we can take the partial antiderivative of m with respect to x, and we can take the partial antiderivative of n with respect to u. The partial antiderivative of m with respect to x is equal to u times x minus x squared divided by 2 to be added to the partial antiderivative of n with respect to u, which is equal to u times x plus the ln of the absolute value of u plus the ln of the absolute value of c equals 0. We will now delete the repeated term, which is u times x, and our equation will become u times x minus x squared divided by 2 plus the natural logarithm of the absolute value of u plus the natural logarithm of the absolute value of c equals 0. We can get rid of the fraction by multiplying each term by 2, which results to 2 times u times x minus x squared plus the natural logarithm of the absolute value of u squared times c equals 0. Now, we will back substitute the value for u, which is x plus y, which gives us 2 times the quantity x plus y times x minus x squared plus the ln of the absolute value of c times the quantity x plus y squared equals 0. Now, we will distribute x to the quantity x plus y, which will give us 2 times the quantity x squared plus x plus y minus x squared plus the ln of the absolute value of c times the quantity x plus y squared. On the other line, I have forgotten to place the squared symbol. I will go back there shortly. Now, by combining like terms after distributing 2, we get x squared plus 2 times x times y plus the ln of the absolute value of c times the quantity x plus y squared equals 0. And here is our final answer.